Video lesson 10.6. Today we'll be dealing with volumes of cylinders and cones. So let's start off with the cylinder. So first things first, notice that the formula is the same as a prism. We've got V equals big B times H. All right, but a cylinder is, again, think of a prism but with a circular base. So that big B that we're talking about is the area of the base, which in this case would be this part right here. So the area of this whole thing. Again, top and bottom would have to be the same. So that big B here is just the area of a circle, which is this part of the formula right here. So that's your big B, all right? And then the height is just how tall the figure is. Now, just like a prism, the base is always going to be in a cylinder, is always going to be the circular part. So again, the top and the bottom are the same, and it's consistent throughout the entire figure. So think of like a can of soup. That's a cylinder. All right, top and bottom. Even if you tilt the can on its side, the top and the bottom are still the circular parts. All right, so to solve these, pretty straightforward. Just plug those values in, the radius and the height, into the formula, and then simplify the expression. But one thing that's unique is that we're now dealing with pi in there because we're dealing with the area of a circle. So we've got to have pi. So I always say don't worry about pi until the very end. Keep it along, let it come around for the ride here. So we've got, let's see what units we got. We got 7 for the radius and 11 for the height. So I'm dealing with the 7 here squared and 11 for the height. All right. So let's simplify this and plug it in. Again, I'd like to leave pi to the very end. So we've got, this is going to be pi times 49 times 11. So that's going to be 50, that'd be 539 pi. So again, if the question says in terms of pi, you are done right here. Let's not forget our units, which is inches cubed. And you're done. So in terms of pi, you're finished. Again, this is why I like to kind of take all these questions when you're dealing with pi. Simplify the expression in terms of pi first, and then go back to your question and say, okay, do I need to actually plug them in or get a decimal or something like that? Because sometimes we have to do other things than just find the volume. So I don't want to be carrying around just giant decimals all over the place. And I don't want to round it early because then I'm going to mess up my overall answer. So always do in terms of pi first and then go and round if necessary. Now, just for this one, this question is saying as a second part, part B, so to speak, find the nearest tenth of an inch. So now I can actually take that and plug it into the calculator. So let's plug this in. So 539 pi, again, that's second, the exponent button from here. Oops, that didn't work. 539 second exponent button gets me pi. Hit enter. So this says the nearest inch. So we've got 1,693.31844 was the number. And we want to round it to approximately 1,693.3 inches cubed. And that would be our rounded answer. All right, so again, in terms of pi, unless they tell you to round, then do so. All right, so the cylinders are pretty straightforward volume question, right? Nothing super tricky. You just need the radius and you need its height. But they like to give the question in more various forms. So because of that. So there's a lot of ways they can give you the information. They can give you the radius, they can give you the height, or give you other things that help you to find that first. And in this case, that's example number 2. So if they give you the circumference of the base of the figure is 24 pi. So they're not giving you, in like the previous one, they gave us this. We're looking for the area, right? Well, they gave us this, the distance around the figure. That's what they gave us. Like so. So we have to use our circumference knowledge to find the radius. So if we go back, we think circumference is pi times d. That's one of our formulas, right? Or I have an alternate form because we need the radius. I could say, well, the circumference is just 2 pi r, right? Because the radius times 2 is the diameter. So I'm going to utilize this format. Again, you can use the first one. Just once you get an answer, divide by 2. Not the end of the world. So let's plug this in here. So I've got 24 pi is equal to 2 pi r. So now I'm solving for r, so I want to get rid of this. This is all multiplication, so I'm going to divide by 2 pi. I'm going to do the same thing to the other side, 2 pi. All right, that's going to eliminate all of that and leave me with r equals. Now the nice thing about this one here is that in this case, on the left side here, pi also canceled out here, which is really nice because then I just get 24 divided by 2, which is 12. That's not always going to be the case, right? So do be mindful if you're dividing by like a pi value. I strongly recommend putting that in parentheses when you plug it into the calculator. Unless you're using the fraction bar in the calculator, then it does it for you. But otherwise, make sure you put it in there. All right. All right, so now that I have that, now we can actually go back here and find the volume. So V is equal to pi r squared h. Now we have an r value to plug in, and we have an h value, which they told us was 9. So we've got 12 for the radius, 9 for the height. We can now simplify that to 144 times 9. And that would be 1296 pi. This one tells us to round to the nearest hundredth. So let's plug that into the calculator. Here we've got 1296 pi. There we go. To nearest hundredth is 2 decimal places. So 4071.50. So that was 4071.50. This is feet cubed. And there's our answer. So like I said, how to find something first, then plug it in. That's how they can sometimes make these more involved. All right, example number 3. In here, they've given us, what? They've given us the radius. Great. That's nice. They've given us the height. Awesome. So find the volume is easy, right? Plug these two things into the formula, we have it. So that's the question. How much would it weigh if it was made of ash wood that had a density of 540 kilograms per meters cubed? All right, so there we go. We got an alternate kind of question going on here. So density, right? You can always identify the density because it has a double unit. It's units per unit. So in this case, kilograms per meters cubed. So when we have that information and we're looking for, in this case, the weight or the mass of the object, right? This is the mass, right? We have a little formula, D equals M over V, which stands for density equals mass divided by volume. And perhaps you had, heard of this or done this in your science class. Very often a formula used there. All right. So the density is just simply the mass divided by the volume, which is why we get those double units. So if we want, in this example, we want the mass. So I'm going to think of this as like a proportion. I'm going to put this over 1 and just cross multiply and say, well, mass would equal then density times volume. So I have the density. They're telling me the density here. This is your density, right? So I have that part, 540. I need the volume. So we have to go off to the side here and find the volume. So let's do that. So volume is going to equal pi r squared h. We know that r is 1.5, so we square that. We know that the h is 3, so that's going to be pi times 2.25 times 3. So that'd be 6.75 pi. So again, I don't want to find a decimal. I'm going to wait. I'm going to hold off. I'm going to take this whole thing, plug it in here. I don't want to be carrying around decimals that are long decimals and craziness. I don't want to round that off yet. So I'm going to take the whole thing and plug it in here. So now I've got the information that I have over here. I can actually now calculate what the mass is. So let's do that. So we got 540 times. Now when I'm plugging in something like this, like 6.75 pi, I always like to plug it in with parentheses. It would not affect you in this example because it's all multiplication. But again, I like good practice because if I was dividing by 6.75 pi, I would need it to be in parentheses or do something else. So it's good practice to do that. So this gives us would be 11,451. And we wanted what? Let's round it to the nearest tenth there. And this would be, in this case, kilograms. All right. So that would be our mass of this cylinder if it was made out of this type of wood. All right. So again, that's a density question. They love asking these types of questions. Again, they can ask you to find the density. If you can find the volume. They can give you the mass. You can find the density, or like this one, they'll give you the density, you find the volume, calculate the mass. So they really love these kinds of questions. So again, just remember D equals M over V. Easy way to remember that. You all want to drive, so DMV, right? Got to go to the DMV in order to drive. So, all right, example number 4. Now we're talking about a cone, right? We want to find the volume of this cone. So one of the things, if you just kind of notice this, and I'm just going to do this real quick. If I kind of sketch this here, all right, if I took this circle, right, this base here, if I took this base, right, if I slid this base all the way up here so that it was like so, right, just so that to the point where that tip of the cone there was touching that circle, right? If I just drop down straight down from there, you notice you get a cylinder, right? So the unique part about this is you now would have 3 cones here. You'd have the cone that we have here. You'd also have another cone over here, right? There's a cone like shape, and you have another cone-like shape over here. All right, now you don't have to draw that and see it, but just it's good to envision. So the unique part about this is that, look at the formula. It's 1/3 pi r squared h. It's just simply 1/3. So when this touches like this, it breaks this up into 3 equally volumed cone-like shapes, right? So all you have to do is take the cylinder formula, right, and multiply it by 1/3, right? So that's a nice little thing to remember. It's an easier concept when you kind of think of it that way, I feel like. So now we can just simply plug in the information. So we've got, this is 12 with a radius of 12 and a height of 6 inches, right? Do be careful of the units. Make sure that you pay attention to them. Sometimes they might be a little tricky. They might be like, oh, this is 12 inches radius, but it's 6 feet tall or something like that. Then you got to convert the units so that they're the same, but not for here. So 1/3 pi times the radius, which we said was 12 squared, times the height, which was 6. So I'm going to simplify this here. So I'm going to do this part here. So we got pi times 144, and I'm going to do 1/3 of 6 just because I could do that in my head easily. That's just 2, right? Again, it's all multiplication, so the order doesn't matter as long as you square the term first. So that gives me 288 pi. All right, so again, leave it in terms of pi unless it says otherwise. In this case here, it does tell me to round to the nearest 1/10 of an inch. So I'm going to plug this into the calculator. That gets me here 904.8 inches cubed. All right, so that's the same thought process here, just a slightly alternate formula with the cylinder, but it's, again, just think of the cylinder formula, just 1/3 of it. All right, and then that's it. So that's really it for that one. All right, moving on. 2 more questions I want to kind of show you guys. Again, this is what happens if they give you the volume. We've done questions like this before. Let's say they give you the volume, but they ask you to find something. So in this case, they're looking for the height. So you're given the radius is 4, you're looking for h, right? So volume equals 1/3 pi r squared h. We know that the volume, so V is 150.8, equals 1/3 pi 4 squared, and we're looking for h. So now simplify everything you can on this side, all right? And then we have to move things over to get h alone. So 150.8 is equal to 4 squared is 16. 1/3 of 16 is not a nice number, so we're going to just leave that as 16 pi over 3, right, times h, right? from here. So now this is, again, where you got to be careful. And this is usually where calculator errors or calculation errors occur. I want to get rid of this whole thing. You could do it in pieces. If you wanted to, you could have kind of like gone and got rid of each thing individually. I like to do it in one piece if I can. So when you're getting rid of here a fraction, I'm not going to divide by a fraction. Instead, I'm going to multiply by its reciprocal. So I'm going to multiply by 3 over 16 pi. And whatever I do to one side, I have to do to the other. So I got to do that on both sides here. That's going to allow this to all cancel out. So I'm going to be left with h is equal to, for this part here. Now, when you're plugging this part into the calculator, right, here, make sure, when you're using this, so I'm going to do 150.8, and I'm going to multiply that. This is a good time to use that fraction bar, right? Alpha y equals, option number 1 will give you the actual fraction bar. I can actually write 3 over 16 pi. All right, from there. Now, by doing it this way, you see 16 pi is nested together down there on the fraction bar. So it'll actually put it together. If you don't do it with this, you'd have to put a parentheses in there. So I'm going to hit enter. So that gives me 9.0002 blah, 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 blah. So we know that h is approximately 9. We don't have any units, so we're just going to say 9 units, whatever that is. Again, these are straight units because it's just a regular measurement. So that's important. You want to make sure you do that. Now, if you didn't, just to show you, like if I did 150.8 times, if I didn't do that and I used the old like 3 divided by 16 pi, so to speak, if I do it like this, I'm not going to get the same answer, most likely because it's telling me it's following PEMDAS. So if I hit enter here, see how I don't get the same answer? I'd have to put all of this in parentheses. I'd have to do 150.8, all right, and multiply that by, and I have to do 3 divided by, in parentheses, 16 pi, close the parentheses of that, close the second parentheses, and then hit enter. So as you can see, it's a lot easier to work with it with using the fraction bar. If your calculator doesn't do that, I actually recommend doing this part first in the calculator and then take that answer and just multiply by 150.8 and make your life a little bit easier. So, but that's all things to kind of take into consideration when you're using the calculator. All right, last but not least, this video is getting a little bit longer than I wanted to. So the last one is the slant height. The slant height is the length on the outside of the cone. So in this case, this part right here, this is your slant height along the outside edge from top to bottom. So this is 17. They're telling you the altitude, big fancy word for height, right, is 15. So they're saying find the volume. So in order to find the volume, I need this piece here. So I'm given the slant height, I'm given this altitude, I'm asked to find this. Well, we know that all altitudes, right, or heights must be perpendicular with the base, right? So therefore I have that. What do I just make? I made a right triangle. So if I'm looking for r now, right, I can just simply use Pythagorean theorem to find it. So now I can use a squared plus b squared is equal to c squared. I can plug in my 2 legs, which would be the 2 sides that make the right angle. So r squared plus 15 squared has to equal 17 squared. Now we can just solve this, right, for each of them. Minus that over, so you get r squared is equal to 64. Square root both sides. Again, I can't have a negative, so r is just 8. So now I have that. Once I have that part, I know that that's 8. Volume formula, pi r squared times h. I can now simply plug this in for my r. So 1/3 pi times 8 squared times 15. This was 15, right? And simplify this. So once again, I'm going to say 1/3 of 15 is just 5. So pi times 64 times 5. And that's going to give us an answer of, what is that? That'd be 300, that'd be 20, so 320 pi. And it says in terms of pi, so I'm done. Nice to know, easy to say. and now we have that information there. So again, this slant height portion here is just simply an alternate piece of information, but if I just utilize our Pythagorean theorem, we can help to find the pieces of the information that I need. And we're going to do more with the slant height, specifically within the pyramid. That's when it happens to come out a lot more often. But I just wanted to kind of introduce it here because this is an easier version of it, so that when we get to that, you'll see how those kinds of things work out. All right, so overall, we have the volumes of both the cylinder and the cone. So take the opportunity, rewatch the video if you need while taking notes, and don't forget to utilize the practice problems for better understanding.